open your books to page 35. We are starting activity 3 called Solving Inequalities, and we're going to look at inequalities and their solutions today. So our first learning target is to understand what is meant by a solution of an inequality. And then we're also going to graph solutions of inequalities on a number line. So a solution of an inequality in one variable is the set of numbers that make the inequality true. So set of numbers means that there's more than one answer or solution. So if we're looking at this table here, this is showing us that Spartan Middle School students need to take a physical fitness test in their gym class, and in order to pass, 12 and 13-year-old girls need to do at least 7 push-ups. So if you look at the verbal description in the first row, at least 7 push-ups, which the inequality underneath that is P push-ups must be greater than or equal to 7. And then if we look at the graph, okay, I have a point or a dot at 7, 8, 9, 10, 11, and so on, all the numbers greater than or equal to 7. Modified pull-ups. They need to do at least 4 pull-ups in order to pass. So M must be greater than or equal to 4, so we have a dot at 4, 5, 6, 7, 8, and so on. The last thing here is their 1-mile run. It needs to be completed in 12 minutes or less. So R has to be less than or equal to 12. So we have our closed circle at 12, and we're shading to the left all numbers less than 12. So why do you think the graphs of push-ups and pull-ups are dotted, but the graph of the mile run is a solid ray? Well, if you think about how you count, push-ups and pull-ups are completed or counted in whole numbers. So when we're counting push-ups and pull-ups, we count 1, 2, 3, etc. But if you think about your running time, it's continuous. It's very accurate. We don't have to count it in whole numbers. Right? We could get 8 minutes and 32 seconds, 9 minutes and 28 seconds, 10 minutes and 52 seconds, and so on. Okay, question 2, we're going to look at a student named Jamie. Jamie ran 1 mile in 12 minutes, 15 seconds, did 8 push-ups, and did 4 modified pull-ups. Pause the video and answer, did she pass the test? And explain why. No, she doesn't pass. Why? Because of her mile time. Her mile time is greater than 12. It said it had to be completed in 12 minutes or less. All right, question 3. We have a new student named Karen. Karen did 7 push-ups. Is this a passing number of push-ups? Which words in our verbal description above indicate this and explain? And question B, how is this represented in the inequality? So pause the video, try your best to answer questions 3A and B. Is 7 a passing number? Yes. So which words in our verbal description indicate this? So if we go back up, we look at our push-ups, our verbal description, it says at least 7. So because of the words at least, that indicates that 7 is a passing number. And if we're looking at our inequality, how do we know from this symbol that 7 is a passing number? Well, this equal to line underneath in our symbol, the line underneath means or equal to, and that means that 7 is included as a solution. So because of our sign, we know that 7 is included. It's an answer. All right, let's take a look at this table. We are only going to focus on the inequality on the right-hand side. And we are going to take these x values and we are going to plug them in to our inequality. So this inequality right here. So what that means, instead of having an x here, we are going to substitute in -1 first. So 2 times -1 plus 3 is greater than 5. So what you need to do is 2 times -1 plus 3. 2 times -1 plus 3. We get 1. Is 1 greater than 5? No. So -1 is not a solution or an answer. We got a false statement. So we're going to take 0, our next x value, and plug it in. So 2 times 0 plus 3. Pause, use your calculator, or maybe you can do it in your head. 2 times 0 plus 3. We get 3. Is that greater than 5? No. So 0 is not a solution or an answer. It's a false statement. So let's plug in 1. 2 times 1 plus 3. 5. Is 5 greater than 5? No again. Okay, let's plug in 2. 2 times 2 plus 3. We get 7. Is 7 greater than 5? Yes, we finally get a true statement. 7 is greater than 5. Let's plug in 8.5. Type that in. We get 20 is greater than 5. Is that a true statement? Yes. So 8.5 is a solution. It makes our inequality true. So, question 6. Which numbers in the table are solutions to our inequality? Well, we got x equals 2 and x equals 8.5. Okay, so if you look at 1, when we plugged in 1, we got 5 is greater than 5, which was a no statement, but as soon as we plugged in 2, we got yes. So do you think that these are the only two solutions to the inequality, and explain? Well, let's see. Let's plug in 5. So 2 times 5, because 5 is in between 2 and 8.5. So that's why I decided to choose it. 2 times 5 is 10, plus 3. We get 13. Is 13 greater than 5? Yes, it works. if we plugged in 10, 2 times 10 is 20 plus 3, 23 is greater than 5. Yes, it works. So are these the only two solutions? No, we just saw that x equals 5 and x equals 10 works. So any number greater than 1 is a solution. Because 1 was false and 2 was true, and any number greater than that is also going to be a true statement. Okay, take a look at question 8. We have two different inequalities in two different number lines. So x is less than 3 is right here, and x is greater than or equal to -2. So what I would like you to do is use this table to compare and contrast our two inequalities in the graphs that are shown above. So write down some similarities that you notice and some differences, and you might need to pause and take the time to do that. So if we're looking, both number lines go from -3 to 3. Both have number lines. They both have shading. They both have x's. Some solutions are the same, which means we shade over some of the same numbers. Both graphs show a range of values. This is a lot more similarities than I was expecting. They both have inequality symbols. They both have solid rays shading with arrows at the end. Okay, let's take a look at the differences here. What is a main difference? Good, our signs are different. One is a less than symbol, one is greater than or equal to. Perfect. Our numbers are different. Good, one has a 3 and one has a -2. Our circles are different. Perfect. We have an open circle and a closed circle. We shade opposite ways, shading different directions. One goes left and one goes right. Anything else? Okay, question 9 says, think about why the graphs are different. Why is one of the graphs showing a solid ray going to the left and the other graph showing a solid ray going to the right? So let's talk about our first graph, or we could call this the graph on the left. This is a solid ray or shading going to the left. Because numbers less than 3 are to the left of 3 on a number line. We're shading to the left, or we have a solid ray to the left, because those numbers less than 3 are to the left of 3 on our number line. So our second graph, or the graph on the right, this time it has a solid ray going right, or we shade to the right, because numbers greater than -2 are to the right. On the number line. So this time our solid ray goes to the right, because those are the numbers greater than -2. Why does one graph have an open circle and the other graph has a filled in circle? We use an open circle when we have a less than or greater than symbol. We talked a little bit about this in our note sheet. This means that the point or the number is included. It's part of our, is not included. It is not a part of our answer or our solution. We're not equal to, it's not included. A closed circle is when we have less than or equal to or greater than or equal to. So this will be a closed circle. Fill it in, color it in. This one is open. This means that point or that number is included. It is an answer. We are equal to it. Look at the check your understanding box, and if you need more room, you can write in the My Notes section of your book. But we are going to write an inequality to represent each statement. So please pause the video, and I want you to try questions A, B, C, and D, because we did this on our note sheet. So 10A says x is less than 12. So x less than 12 is how we would write it. Question B, m is no greater than 35. So I'm going to start with my m and then my 35, and I need to fill in my sign in the middle. No greater than. Ooh, that means less than. We could be equal to 35, just not bigger than that. So m is less than or equal to 35. Question C, real life example. Your height h must be at least 42 inches for you to ride the roller coaster. So think about this. Cedar Point or Michigan Adventure, you would not put a baby or a 3-year-old on the roller coaster. Okay? They're not big enough. They're not tall enough. So your height, h, must be at least 42 inches tall. If you, as a freshman, are taller than 42, then you can ride. Somebody who's 6 feet tall can ride. So your height must be greater than or equal to 42. A child's age A can be at most 12 for the child to order from the children's menu. So if you go to a restaurant, think about who can order from the kids' menu. Can your grandma get away from ordering from the kids' menu, or your parents, or your older siblings, or you? Me, I can't get away with it. But think, if we had a 2-year-old, or a 5-year-old, or an 8-year-old, they all can order from the kids' menu. So age has to be less than or equal to 12. Question 11. It says, how are the graphs of x is greater than -4 and x is greater than or equal to -4 alike, and how are they different? And I gave you a hint to graph them first. So in the My Notes section of our book, let's draw 2 simple number lines. And we're going to put -4 in the middle. I'm going to go 1 number on either side of it, so nothing too fancy. Pause the video and try to graph these, and then think and write down how are they the same and how are they different. Open circle at -4, and I need numbers greater than that, so I'm shading towards the right, towards -3, 0, 5, and so on. X is greater than or equal to -4, so I'm going to fill in my circle this time. And I'm still greater than, so we're still shading towards the right. So how are these similar? They both have circles at -4. That's our number for both of them. And they're both shading to the right because our signs are greater than. A difference here is the circles. One's an open circle and one's a closed circle.